Okay, good morning, guys. So what I want to look at today really is combining metals and non-metals. So basically what this means is that when you, for example, we know that we can form compounds and molecules by joining together different atoms. Um, and what I want to focus on specifically is when you have metals, which again, if we remember, so group 1 and group 2, these guys are known as the reactive metals, and then you have non-metals, which are all these guys here that are in green. Okay, so there's some in group 3, 4, 5, 6, and 7. Um, how do they combine, and then also like how do we go about naming them? So as an example of that, if we take sodium chloride, okay, so sodium chloride. So this is what's known, this is common table salt. So we have sodium, which is Na, chloride, NaCl. Okay, so you have the sodium and you have the chlorine. Now, if we look on the periodic table, so we have chlorine here, okay, and then we have sodium over here. And this is what's known as sodium chloride. Now, another way to think about this is so we're taking a metal, which is the sodium, and we're combining it with a non-metal, which is the chlorine, to create sodium chloride. So you have sodium plus chlorine gives you sodium chloride. Now, if we think about that, let's look at that from the point of view. So remember, sodium, we can write it like this, so Na, and then what we can do is on the outside here, we can put the one electron that's in the outer shell of sodium. So if you remember, when we look in the periodic table, group 1 elements, if we look at the very outer shell, group 1 elements have one electron. So in the case of sodium, we're not worried about any of the other electron shells, we're just worried about the outside shell, and it has one electron. And when we draw it like this, this is a different way that we can represent and draw these chemicals. And then if we think about chlorine, so chlorine, remember if we look here, it's a group 7 element. So that means it has 7 electrons in its outer shell. So again, we can just represent the electrons with circles. So we've 1, 2, 3, 4, 5, 6, and then 7. So sodium wants to lose one electron and chlorine wants to gain an electron. So what's going to happen is sodium will lose this electron and chlorine will gain it. So what will happen then is when sodium loses that electron, it'll have one proton more than it has electrons, so therefore it'll have a positive charge. It'll have a +1 positive charge. Chlorine will gain an extra electron, so it will have one more electron than it has protons, so therefore it'll have a negative charge. So these will become charged ions, and then what's going to happen is this positively charged ion is going to attract this negatively charged ion, and then you'll get your compound forming, which is sodium chloride. So essentially what you're getting is the combination of a metal with a non-metal. So remember, these are the metals and these are the non-metals. Now what we need to think about is how do we go about naming. So when you have a metal and a non-metal, how do you name the metal and non-metal? Well, the way that you do it is when you combine a metal and a non-metal, the name of the metal comes first, followed by the name of the non-metal, and then the ending changes as well. So you start off, so for example, this is our metal, sodium, our non-metal, chlorine, we add them together. So you start off with the metal name, which is sodium, and you end with the chlorine name, with the non-metal name, which in this is chlorine, and then you add in this IDE at the end. So see, you have this IDE. So that's when you're naming it, you start off with the metal, and then so it's the metal first, then the non-metal, and then you change the end into IDE. So it becomes sodium chloride. So what I'd like you to do then, so I'd like you just to pause the video and try and work through these questions here. So what are the names of the compounds formed between calcium and chlorine, lithium and bromine, and magnesium and oxygen? So I just want you to do like this, a dot structure like this, and just write down then what you think the names of each of the compounds are. Okay, so let's have a look at these then. So calcium and chlorine. So if we have a look at where calcium is on the periodic table, it's in group 2. So you've calcium here is a group 2 element. If we look at chlorine, so chlorine is a group 7 element. So chlorine. So if we think about it, so calcium, if you were to write calcium, it would look something like this. So it's going to be Cl, and it's going to have, because it's in group 2, it'll have 2 electrons in its outer shell. And then if we think about chlorine, chlorine is going to have 7 electrons in its outer shell. So 1, 2, 3, 4, 5, 6, 7. So remember, chlorine is a chlorine. So calcium is a group 2 element, so it's two electrons in its outer shell. Chlorine is a group 7 group 7 element, so therefore it's going to have 7 electrons in its outer shell. Now what we want to think about here is that, so chlorine actually wants to lose, the quickest way for it to become stable is to lose these 2 electrons out here, okay? And chlorine wants to gain 1 electron in order for it to be stable. Now, in order for calcium to be able to lose these 2 electrons, it has to give them to an atom that's able to take the electron, okay? So if you think about if you think about calcium, should I say, and I should write this symbol here, it should be Ca. So Ca. So that's calcium. So that's the right symbol, that's the proper symbol for calcium. I had it written down as Ca. Now what's going to happen is calcium wants to lose these 2 electrons. In order for it to lose the 2 electrons, it has to have an atom or atoms that will pick up these 2 electrons. So if we think about, if it's going to combine with chlorine, like each chlorine atom, one chlorine atom can take 1 electron, because in order to have a full shell, it can take up, it needs 8 electrons. So it has 7 as it is, and each chlorine atom can only take 1. So what you're actually going to need then, you're going to need 2 chlorine atoms. Okay, so let's say, so these are our 2 chlorine atoms. And what's going to happen is this calcium atom is going to give up. It's going to give one of its electrons to this chlorine, and it's going to give the other electron to this chlorine. So what will happen then is it'll lose 2 of its electrons, and as a result of that, it's going to have 2 less electrons, and as a result of that, it's going to have a +2 positive charge. Okay, so it's going to become an ion. And chlorine then, on the other hand, each one is going to gain 1 of the electrons. So it's going to have, so each chlorine, so each one of these, and I'll just draw this down here, just move it out of the way. So each of these chlorine atoms, then, I'll just make a copy of them. So each of these chlorine atoms are going to have an extra electron, and I'll just, maybe if I do it in red, I just highlight it a bit better. So each of these chlorine atoms is going to have 1 of the electrons that's after receiving from the chlorine atom, and as a result of this, each of these will have a +1 positive charge. And as a result of that, then this chlorine ion will combine with this calcium ion will combine with these 2 chlorine ions. So it'll be something like CaCl2. Now, how do we name this then? So the way that we name it, it's going to be called calcium chloride. So remember, you take the metal, which is calcium. So it's going to be calcium chlor, CHLOR. So you change the ending. Instead of having I and E, you're going to have, like what we have up here, IDE. So it's going to become an IDE. So it's going to become calcium chloride, IDE. So that's how. So this will be the chemical structure for it, and this is the name. So it's calcium chloride. The calcium comes from the metal calcium part, and the chloride comes from the non-metal chlorine part. Now, if we think about, let's have a look at lithium and bromine. So if we have a look at where lithium is on the periodic table, so lithium is a group 1 element. So again, we can write our group 1 element like this. So lithium, so we have lithium, and it has 1 electron in the outer shell because it's a group 1 element. So remember, so the Li represents the chemical symbol for lithium, and then this 1 dot here represents the 1 electron in the outer shell. And then if we think about bromine, so where is bromine on the periodic table? It's a group 7 element. Okay, so it has 7 electrons in the outer shell. So bromine is going to look something like this. So it's 1, 2, 3, 4, 5, 6, and 7. Now, as a result of that, chlorine wants to lose 1 electron, bromine wants to gain 1 electron. So, sorry, lithium wants to lose 1 electron and bromine wants to gain 1 electron. So it's going to, lithium will give up its electron to bromine. As a result of that, it will become a positively charged ion. Bromine will gain the extra electron, 2, 3, 4, 5, 6, 7, and then it'll have this extra electron in here, 8, and as a result of that, it's going to become a negatively charged ion. These two will come together and you'll get lithium and bromine attached together. And remember, this bond, when you have a positively charged ion and a negatively charged ion coming together, this is what's known as an ionic bond. So how do we name this? Again, we name it, we use the metal part first, so it's lithium. And then we use the non-metal part and we just put IDE at the end. So it's going to be lithium bromide. Lithium bromide. So that's how we name that one. And then if we think about magnesium, so where is magnesium on the periodic table? So magnesium is a group 2 element. So magnesium is going to have 2 electrons in its outer shell. So we can just write it like this, magnesium. So it has 2 electrons. And then oxygen, we look at where oxygen is on the periodic table. It's a group 6 element, so therefore has 6 electrons in its outer shell. So it has 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. So remember, oxygen wants to gain 2 electrons, magnesium wants to lose 2 electrons. So it's going to give up these 2 electrons to oxygen. So magnesium will become a +2 positively charged ion, and oxygen will become, so you're going to have oxygen be like this. Oxygen is going to become a -2 charged ion. And then what's going to happen is these 2 oppositely charged ions will come together and they'll form an ionic bond. So you have magnesium oxide. So again, remember, how do we name this? We use the metal part of the name first. So the metal in this case is the magnesium. And then we use the oxygen. So it's OXIDE. So it's magnesium oxide. Now, another important thing to kind of think about as well, if we have a look at the ratios of the bonding between the atoms. So if we take the case of sodium chloride, for example, that's bonded in the ratio of 1:1. So you have 1 atom of sodium bonded to 1 atom of chlorine. Now, you can make predictions in relation to the groups, like where the atoms are in the periodic table and how they will bond. Like if you think about sodium, for example, sodium wants to lose 1 electron, so therefore you could say it has a bonding power of 1, and chlorine wants to gain 1 electron, so you can say that it also has a bonding power of 1 as well. So as a result of that, 1 atom of sodium will bond with 1 atom of chlorine. If we think about calcium, on the other hand, this is bonding in the ratio of 1:2. So you have 1 chlorine atom bonding to 1 calcium atom bonding to 2 chlorine atoms. So if you think about chlorine, for example, it wants to lose 2 electrons and chlorine can only gain one electron, so therefore it's going to bond in a ratio of 1:2 based on that. If we think lithium, for example, lithium wants to lose one electron, bromine wants to gain one electron, that's going to be bonding in a ratio of 1:1. And then the same if we think about magnesium and oxygen. Magnesium wants to lose 2 electrons and oxygen wants to gain 2 electrons, so therefore it's also going to bond in a ratio of 1:1 atom. So like really what we're talking about there is just the ratio of how the atoms join together. Now just an important kind of general kind of rule then as well. Like if we take the group 1 elements, they all have 1 electron in their outer shell. So what they will generally do is they'll lose that outer electron and they'll become a +1 positively charged ion. If we think about group 2, they have 2 electrons in their outer shell. They will generally lose those 2 electrons and become a +2 positively charged ion. Then if we think about, let's say, if we go over this side, then if we think about the group 6 elements, generally what they want to do is they want to gain, they have 6 electrons in their outer shell, they need 8, so they want to gain 2 electrons. So generally they'll become a negatively charged ion with a +2 negative charge. And then if we think about chlorine and fluorine and all of these group 7 elements, they have 7 electrons in their outer shell. So generally what they want to do is they want to gain 1 extra electron in their outer shell, and as a result of that they'll become a negatively charged ion. So that's just a general way that group 1, group 2, group 6 and group 7 elements will, like basically what they will do, they'll generally turn into ions and they'll form ionic bonds with non-metals. So what we've really looked at there is just combining metals, which are these red group here, with non-metals, which are all of these green groups here. So again, it's just important as well, so kind of a new part that I've introduced there is this idea of the ratio. So when you look at atoms and where they fall on the periodic table, you can kind of make, and if you were to pair up 2 different types of atoms with each other, you can kind of make a prediction on how they're going to combine with each other, and then what's the ratio, like how many of one atom will there be in relation to the other atom. So you see, like when we have calcium, for example, it has 2 electrons in its outer shell. If you want to combine that with chlorine, you need 2 chlorine atoms for every 1 calcium atom. The reason being is that calcium has two electrons to lose in its outer shell for it to be stable, and whereas chlorine, an atom of chlorine can only take 1 electron. So as a result of that, if you want to combine calcium with chlorine, you need 1 atom of calcium. You need 2 atoms of chlorine for every 1 atom of calcium, and you'll get a ratio of 1:2. And that's just based on where they're positioned on the periodic table. The same as if you have, for example, magnesium and fluorine, you will need 2 atoms of fluorine for every 1 atom of magnesium in order for that combination to happen. And that's what's known as the ratio of the bonding. So guys, so that's just a general introduction. Again, it's just kind of recapping some of the stuff that we've done, and it's just a general introduction where I want to kind of look at how do you make predictions. Like now that we know like what drives chemical reactions and atoms bonding with each other, how do you make predictions in relation to the different groups when they start reacting with each other. And also as well, the other thing that's just important when you're naming, so when a metal combines with a non-metal, you want to give that new compound or molecule a name. You will generally give it the name, so the name of the metal part will come first, followed by the non-metal part, and you'll add an IDE at the end. So for example, when sodium combines with chlorine, you get sodium chloride. The same as well as we've seen down here, when you get lithium combining with bromine, you get lithium, which is the metal part, bromine, which is the non-metal part, and then ide indicates that it's a metal combined with a non-metal. And the same with magnesium oxide, okay, they become ides. Calcium chloride, okay, so again, that's just important as well. Okay guys, thank you.